So in this step, we're going to deal with the train to split and the pretend model initialization, where we're going to load the ResNet 50 pretend model and then we configure the lower layers of the pretend model to have a class of true, but I actually wanted to add something onto the visualization. So essentially in the visualizations, we can also put the title in this way. We know the label index. So what I can do is I can get the numpy of that. After getting the numpy of that, I get the index of the maximum value, which in this case is 1. Yes, and then after doing that, I fetch the labels, and so then I can also get to disable the axis of the pictures. So this one label is not defined. This is labels, so labels. Yes, so we get to have the labels of the cats, dog, cat, dog. Yeah, that's what I wanted to speak. So let's continue onwards. So trying to split, we are going to use the TF dot the cardinality. Cardinality is essentially the number of batches in data. So we're going to use it to divide the cardinality. So let's say train dataset. So we're going to use it to get to have the trained dataset. So I'm going to say train dataset. Say trained dataset. Skip train purchase. So if I want to use 10%, I'll do this way. If I want to use 50% of the trained dataset for maybe, so like here I would say 10, then here, so let's say if there's a trained dataset, then validation dataset. So here essentially I take 10% of the trained dataset over to the validation dataset, and then the rest 90% I still maintain it in the trained dataset. Then if I wanted to take maybe 50%, then it would be 2. So if maybe we wanted maybe 20%, it will be 5. So that's how we go. So since I want only 10% of the trained dataset in the validation dataset, I'll do that. Then after that, I want to delete, since I don't actually need this anymore. So therefore delete it. Yes, so by deleting it now, we get to have see that the number of batches in the trained dataset is okay. Yeah, so the thing is, when you unbatch and you map again, the effect is actually this one. So that's why it's usually important to define all the functions that you have, then you map it onto the TensorFlow dataset. Because if you unbatch and you map again, the error becomes this one. But let's say if we had never mapped in the first place, let me just copy the code that we had never unbatched in the first place. So coming back to this point in time, so yeah, we copy it. So if we had never unmapped, so if let's say I change this one to GR, so now it will be okay. So one other thing that could have been done, instead of unbatching then mapping again, if in case you wanted to view the number of batches, but if not, you could just continue. But if you wanted to view, then what could have been done is this one. So in the trained dataset, essentially, let me create a cell above. So we have the train dataset. So as I had said, sequential mapping. So I just on here, and then I take this part, take this part here, then I actually replace here. So if I run it, yeah, now if I get to run this part, and now if I run it, yeah, we see now it's the test dataset. Since we did the unbatching and then we mapped again, is having -2. So yeah, you could do the same for the test dataset in order to get to see the number of batches in the test dataset. So after doing the train test split, we actually now want to deal with the transfer learning. So I want to use the result 50. So just have to import it. Then I initialize the base model. So I don't want the top, since the original last layer with the result 50 was for ImageNet classes. That's 1000. I actually don't want that one, since I'm going to use only 2 classes. Then I want to freeze the earlier layers because I won't be training that part. Yes, and then now I want to define my own. So I'm going to use the the functional API. The input is actually image size 300 by 300. So I'm going to change the input to the image size 300 by 300. Then it's passed to the base model. Then after that, we get that we actually see that the last layer of the base model so the last layer of the base model, and get to want to get the output shape. So we want to get our output shape. So okay, what I want to do, let me see. Yes, the last layer is 2048, so it's we get to do a global average pooling of the output of the base model, then we flatten it, then we introduce our custom lower layers, dense, dropout, dense, dropout, of course the activation value, which essentially reduces the negative values of the weights to 0 and does not interfere with the positive values. And then dropout is a regularization technique. Then after that we have the last layer, which is the dense 2. So then using the functional API we create the model, yes, from the network of graphs which we have defined to be used to know our architecture. So now I just have to run it. Then when I get to have the model summary, we see that the trainable parameters are only 133,568 out of the 23 million. Yeah, so we have frozen the upper layers and we are only going to train the trainable layers from here downwards. Yeah, so that's it with this step. And now we are going to the last step, which is the custom training loop using TensorFlow. Yeah, so yeah, let's open to the next step.